Okay, so value this will be y, I think. Any of them, sure. So anywhere we see I, we put y. And anywhere we see j, we put x. Okay, so at the end of the day, return array. Okay, so let's test it out here and see if it works. We comment out this and we say swap array, and x is, well, j, and y is I, and yes, it works. So we can try it with something else. Let me say we want to swap 1 and 4. 1, 4. 1 was 3 and 4 is 2, and it swapped them. So our swapping function is working. Okay, so in here we can just say if array square bracket j is greater than array square bracket j plus 1, what do we do? Swap array j and j plus 1. That's it. So this is our array. Let's console log bubble sorts.
Please, a quick question, please.
Yeah.
Why do we need to put array in front of the swap? Yeah, I mean in the parameters.
Parameters. Why do we need to put array? Is that what you're asking?
That swap function. Why do we? Yeah, exactly.
Because we're trying to swap.
I mean for the swap, swap function.
Yeah, that's this now. See?
Okay. Yes. Okay, I've seen it.
Okay. So this.
I'm sorry.
This this is not getting us what we want yet. So any idea why?
Sorry, please, can you go back to the code and let me just see what we are trying to do?
Can I go back to where?
No, let me just go back. The question, let me just see what we are trying to do.
When did you join this class? When did you join this class? Because this one you're talking of Christian. That's surprising me. Anyway, we're looking at bubble sorts.
That's not possible.
So I think the issue is from here. We did not this value that we got from this swap, we didn't use it. We just swapped and left that value hanging. So we say array is equal to swap. I think nothing still changed. Let me see. Let me try something. Console.log array, and as well console.log array. So this is 53412, and after the swap we have this. Oh, should I put this in a different function? Okay. Oh, I see. Wow. So that's just all that was left. Yeah, I was supposed to get to array.length, not stop at array.length minus 1. So that was what caused this. So let me see, minus 1, and we get weird values. Okay, see, this was sorted. 1, 3, 4, 5 is sorted. It's just 2 that is left where it originally was. So let's try and understand why it needs to get to array.length and not stop at array.length minus 1. Okay, so these are let me remove this. So with I getting to array.length, that means for in this example now there are 5 things. So basically I is 5, right? And I is stopping before 0. So J is stopping, okay, at the first place is stopping, okay. Stopping at 4. I is stopping before 4. Alright. This I minus 1 already took care of that minus 1 thing I was trying to avoid here, but I forgot about that. So yeah, that's why. So this is our bubble sort, algorithm. From the pseudocode and from what we explained, this is clear, Abby. Let's try adding a few things into it. Minus 1. Okay, 6. 1 alpha, 1.5. Alright. So, all working. So, for the last time, any issues with bubble sort? No issues. Okay, so we move to the next. The next is selection sort. And you see, in bubble sort, we cared about the largest number, right? We wanted the largest number always to bubble to the top or bubble to the end. In selection sort, we care about the smallest number, the smallest value. We will go through each time and find the smallest value and put it in front. Every time, find the smallest value, put it in front. Smallest value, like that. Okay, so that means, if we had an array like this. Okay, I've done things to this array. Yes, if we had an array like this, we go through 1 is the smallest number. We carry 1 and put in front. 1, comma, this, then we remove this one, right? So now we will not look through the entire array anymore. We will now start from here to the end. Look through, which is the smallest? 2. We put it at the back of, the sorted portion of the array. 2, and we remove this 2. Or actually the real thing here is a case of swapping. This is a very classic what's that thing called? Multiple pointer algorithm, right? This was how it was. So we have our I here, back. So we have our I here, and then we keep checking. Let me say this is J. Is J smaller than 5? Yes, J becomes, we mark that value, as the smallest value and keep checking. This is smaller. No, it's not smaller than 3. Like, we have a separate something, smallest value. Let me say smallest is equal to 3. At first it was 5, but when J came over here, or rather when you compare these two, smallest is 3, j moves on, we see 1 is now smaller, so we say 1, j moves on, 2, is it smaller? It's not smaller, so we swap, or rather it's not really storing the value, to store the index. So the index of this is what? 3, Abby. I is 0, so it would swap 3 and 0. So we have 1, and this will become 5. On the next turn of the loop, I will come here, and j will start checking again. 3 and I will become the new smallest, 3, right? Yeah. So 3 and 4, which one is bigger, smaller? 3. So j moves on, no wahala. 3 and 5, 3 is still smaller, moves on. 3 and 2, 2 is smaller. So this index 4 and this index 3, sorry, 1. 4 and 1 is swap, so 2 would come here and 3 would come here. Like that, it will move again. Check, check, check. Whatever the smallest value among these 3 is, we'll swap that with this one. That's if at all it's not this one, we'll swap. So 3 and this will become 4. Like that, I will move on to here, and then to check these two, 5 and 4, swap them. 4 becomes 5, or 4 switches with 5. So that's how selection sort works. Regarding this little explanation, at least on the workings of selection sorts, is it clear how it works? After this, we'll look at the pseudocodes.
Yeah.
Okay, alright, so we'll look at the pseudocodes, and then we'll try and convert that to actual code. So store the first element in a variable. Somebody needs to mute themselves. I think it's Charles. Charles needs, okay. Alright, store the first element in a variable for the smallest value. Look through the array from beginning to end. Compare whatever item you are on to the next in the array until you found a new smaller value. If a smaller value is found, use it to replace that value in the variable, and continue until the end of the array. If the minimum is not the same as the index you started with, swap the two values. Rinse and repeat until the end of the array, and return the sorted array. So if we were to write that, so function selection sort takes in an array. Okay, so we look, creates the element. Store the first element in the variable for the smallest value. Let smallest be equal to okay, I think this should be done in the loop actually, because we would have troubles if we, let me swap this. Yeah, so for let I be equal to 0, I is less than array.length I++. So let smallest, where did smaller come from? Okay, because of this. Let smallest be equal to array square bracket 0, or perhaps array square brackets I think. Yeah. So compare this item to the next in the array until you found a smaller value. I missed a step here. There's a second loop actually. There's a second loop. So in here you're going to have a loop going from, for let j be equal to I think. Yeah, and j less than array.length. Yeah, because if we look at how it was explained, at the first time you start, start from here and keep checking to the end. Next time you start from here, check to the end. Next time you start from here, check to the end. So they are both stopping at array.length and j++. Do we have a recorded video for this? Well, there kind of is, just didn't start from the beginning. So take out. So each time we check j yeah, we check array square bracket j. Okay, no. Yeah, is array square bracket j less than smallest, right? Smallest. Then what do we do? That value becomes the new smallest, right? If we made that value the new smallest, then how would we know? Let me say we make that index. Yeah, it's the index I think we're supposed to make the new. Smallest index is equal to I think. Yeah, somebody is in again. Okay, so if we meet any value that is smaller than smallest, then let me see. We say smallest becomes, array square bracket j, and smallest index becomes j. Yeah. So at the end of this smaller for loop, if smallest index, is not the same as I, yes, yeah. If smaller index, yeah. So if the minimum is not the index you started with, swap the two values. So at the beginning here, smallest index I is the same as I here, but it may change inside this loop. So if I is not equal to smallest index, then swap. Okay, if I is not equal to, that's true, thank you. If I is not equal to smallest index, then swap. Then array is equal to swap. Remember we wrote the function that we can use everywhere. So we swap I and smallest index. Okay, so this is just going to continue until the end. And after this, we return array. So let's try it again and see if this was done properly. selection sort. Can you guys give me numbers? Fabricating numbers is hard.
4, 10, 16.
10. That's true. I have an issue. So I guess it works, right? -5. Okay. So I think I need to modify this pseudocode. Some things in here didn't show up. Okay, so the first thing is look through the array from the beginning to the end. Yeah. But now I'm thinking, yeah, we do need these two variables, right? Because you always need to check. No, actually you don't. If we just stored this, I, and then each time we check if array square bracket j is greater than array square bracket smallest, then we just need smallest to become j and move on, right? This doesn't work anymore. Okay, because of the smallest index. Okay, so if I is not smallest, yeah, so that was it. Okay, so it wasn't store the first element in a variable for the smallest value, but store the first, and when I say element index, yeah, store the first, no, just first index. Store the first index in a variable for the smallest value, a variable that holds the smallest value, or at least holds the index of the smallest value. So compare this item to the next in the array, which is what we're doing, until you found a new smaller value. So if a smaller value is found, then you use it. Okay, is this compare this one, this was where it became confusing. So now loop again. From where now? From I to the end of the array. From I to the end of the array. Then compare array square bracket j with array square bracket smallest to, or let's say check if array square bracket j is smaller than, check if array square bracket j is smaller than the value at the stored in smallest, right? So if it is, use it to replace the value in the variable and continue to the end of the array. Use j. Yeah. So, yeah, if the minimum is not the index you started with, that's what this is. Swap the two values. So, you rinse and repeat until the end of the array, and you return the sorted array. Are there any issues with selection sort? Hello, people.
It's confusing though.
It's confusing.
Confusing.
It's
It's confusing.
confusing. It's confusing.
The way it is arranging, the way array is arranging itself, it's confusing me. I don't know why I'm not able to wrap my head around this.
Okay, so let's do something like we did here. Let's do something like that for this one. This was, how was it? 5 3 4 1 2, right? 5 3 4 1 2. Okay, so this is the array we're working with, or let's assume this is the array we're working with. The first turn of the array, or rather the first turn of the loop,
Okay, please, we should start from the swap
we should start from the swap.
function.
You don't understand the swap function.
Maybe that's where it's confusing.
The swap function should not be confusing now. You understand exactly what it's doing. It's taking an array and taking two indexes, and it will just swap what is at those two indexes. Like this. This is array 5 3 4 1 2, right? We say swap array 1 and 4.
Okay.
Okay. All right, back here. So here, let me see. Let's call it SM. That's smallest stuff. So SM is equal to 0, for example. So we check 5 and 3. 5 and 3. Is 5 smaller than 3? No. So SM would change. SM would change to 1. 3 and 4. Which one is smaller? It's still 3. So nothing happens. 3 and 1. Which one is smaller? 1. So SM just holds the index of the smallest value. So SM is going to change to this. And this is 3, right? That's 3. 0, 1, 2, 3. Yeah, that's 3. So
Yes.
2 and 1. 1 is still smaller. So at the end of the first loop, the thing is just going to swap these values. So it will swap 3.
Okay, that's swap now. What now happens?
Like this. It will the original in all this let me see. The screen is frozen.
Yeah.
Wow. Is the screen frozen for you guys? It's back. Okay. I is equal to 0 up until this point, right? So it's just going to check, is SM the same as I? No. So it would swap these two indexes, 0 and 3. This was index 0, this is index 3. To just swap their values. So now index 0 would have 1, index 3 would have 5. Then it would not loop again, or the loop would turn the next time. Next iteration of the loop, I is now 1. So it will ignore 0. It will start checking from here. SM SM would be 1. So now I have to check, obviously the item at index 1 is the same as the item at index SM, like the smallest index, is the same as the same value as the item at index I. So to check 3 and 4, 3 is smaller. 3 and 5, 3 is still smaller. 3 and 2, 2 is smaller. It's just checking the value itself. 4 and whatever is at this index, 4 is bigger. 4 and whatever is at this index, 5 is bigger. 2 and whatever is at this index, 2 is smaller. So the index of 2 would now replace whatever is in SM. And the index of 2 is 4. So SM would now be 4. So it has gotten to the end of the array. To check SM and I, are they the same? No. Swap. I thought somebody entered just now. Okay, yeah, they are not the same, so swap. And it's swapping 1 and 4, so 3 and 2. So this will become 2 and this will become 3. I has moved on to 2. So once more, SM would start out as I. SM will start out as 2. That's this. So 4 and 5, which is smaller, 4. 3, is it smaller than 4? Yes. So SM will change once more. SM will become this index. This index is 4. SM is 4. So now the loop, this inner loop has ended. SM and I, which is, are they the same? No. Swap. Okay, this was 2, this was 3. So the item at index 2, which is this, and the item at index 4, which is this, swap. So this will become 3, this will become 4. I will move on. I will become 3. Once more, initialize SM as I, which is 3. So 5, is it smaller than the item at index 3? No, they are the same thing. 4, is it smaller than the item at index 3? Yes, this is the item at index 3. 4 is smaller than it. So give SM a new value, because we found a smaller number now. So SM, remember SM only holds indexes. It doesn't hold, actual values. It don't hold indexes. So SM once again will be 4. The inner loop has ended. SM and I, are they the same? No. Swap. And so we see this 5, index 3 and index 4, this 3 and 4, they will swap. So 4 comes here, 5 comes here. I will become 4. Right? And at 4, well, there's no point actually. So actually we should just get to.
So I have something to say.
Yeah.
So instead of just comparing it to yourself, why not make J equal to I plus 1?
Okay.
Like instead of starting from itself, to move.
To just move on.
Just move immediately, because you can do just the same thing.
Yeah, that's a nice one. So we still get the same answer, showing that true. He has made a little change that has optimized the code. But in any case, we get how it's going, right?
Yeah.
Yeah, I understand it.
Yeah.
Yeah, I understand it.
Wait, please, can I just see that what is this? The swap. Okay, the swap function.
The swap function. So this is an array x and y. So we store the value at index y in a variable. Then we give that index the value at array, the value at index x. Yes.
So that's the swapping.
That's the swapping, and then it's return the array because, well, everything has swapped. So the value at y, store it in a variable, then that index, give it the value at index x, and then index x, you give it back that value from y that you stored. So it just swaps the values at both indexes and returns the array with the thing swapped. And so bubble sorts and selection sorts are done, and we can see that they are working. So okay, got a bit of time. So next we'll go into insertion sorts. So insertion sorts is a bit different from the other two. Those other two cared about biggest number and smallest number. Insertion sorts, what it does is just you pick an element in the array. It starts from the second one, it doesn't start from the first, because like our friend just helped us with, there's no point starting from the first. So it's about, growing a sorted portion of the array and going forward. And each time, so let me just explain. So you start from the second one. You assume that this first number is the sorted portion of the array. So you pick this number and you just go back and check. In this sorted portion that has only one item, where should this one be? Should it be in front or behind? It's smaller, so it goes in front. So we now have, it's smaller, so it goes, okay. I wish I could give this a separate, color, so that I would know that this is the sorted. Or let me just keep something on top here. Right? This is the sorted portion of the array. Okay, so now here, 3, where would it fit into this sorted portion? Oh, this thing pushed it forward. 3, where would it go? It would come in front here to be like 3, 5, right? So the sorted portion moves forward. This is the sorted portion. Now 4, let me just continue on this line, or since people will read this later. 4, you check 4 and 5. Is it, is 4 smaller than 5? If it's smaller, you move a pointer forward. You check 3. Is it smaller than 3? No. So 4 should be here. So you move 4 here. What did I do? You move 4 here. Your sorted portion has grown. So you see how it goes. You pick the next value and you look for where to insert it. That's why it's called insertion sort. You pick this one now, and you say smaller, it's smaller than this, it's smaller than this, so you insert it here. So 1, this, and then you remove this. So our sorted portion has grown. So next we'll pick 2 and decide where to keep it. So 2, it should be before this, before this, before this, after this. So it comes here. And at this point, I has reached the end, so that's it. We don't finish. Okay, so what do you guys think of insertion sort? Is it nice?
It's almost like selection of my
Almost. Really? Well, I guess since it's looking for
arrangement.
the arrangements, let me see. Well, I guess in a way, yeah, it's true. It's kind of similar. It's just that you're not swapping anything. Instead, you are inserting. So
Yeah.
our swap function will not be used here. So we'd have to write something else. Okay, so let's get to writing the function. Function, what's it called? Insertion. Insertion sort, we pass an array and we return the array. So what happens first? We start by picking the second element in the array. So that means our loop should just start from 1 and get to the end. Okay. So for I is equal to 1, I is less than array.length I plus plus. Okay, so we compare the second element with the one before it and swap if necessary. Now this thing makes it sound small, but actually this is not just compare with the one before it, it's more like compare with the ones before it. Whoa. Okay, it's more like compare with the ones before it. At this point, yeah, we just had to compare with one thing, but subsequently, you know, here we had to compare with more than one thing. So let's write a function that we need a helper function that would, right? Oh no, instead we should just write a for loop, because now at every point we have to go back. Let's say here, for example, when we are selecting 2, you know, to go, we have to check, is it smaller than this, is it smaller than this, is it smaller than this. So if it's smaller, okay, actually we can swap at every time. I don't think we can abandon our swap function, right? Is there so much of a need to abandon the swap function? Because if you think of it, when we're trying to move 2 to this place, we could swap with 5, swap 2 with 4, swap 2 with 3, like that. You understand what I'm saying? Hello?
Yeah, I can.
So we don't really need to abandon our swap function. We can still use it here. So each time inside this loop, we pick where would we loop from now? We would loop from I. Yes, we would loop from I minus 1 to 0, and we'll be going backwards. So here, I is 1. I is 1 here. Let me see. So that means that here I is 3. So we start from I minus 1, yeah, which is 2. We go to 1, go to 0. Fine. So for j is equal to I minus 1. Okay, and then j being greater than or equal to 0, because j can get to 0, and j minus minus because we're looping backwards. Okay, so if this is J, right? At every point, if I is here, if array index I is less than array index J, swap. Array is equal to swap array I and J. Yeah, so that's it. At every point, I think we need to put an else. Yeah, we need to put an else. Else break. For example, was there an example of such a situation? Yes, I think here, right? When we're going backwards, 2 is smaller than 5, you swap them. So 2 will become here, or 2 will come here, 5 will come here. 2 is smaller than 4, you swap. 2 is smaller than 3, you swap. 2 and 1, 2 is not smaller, so we break at that point. Do you guys understand that?
Can you explain this break? I think that's what I don't understand.
Okay. Okay, let me explain it well. Ideally, right, in this place, 2 is smaller than 5, so we swap them. 2, 5, and you take coming. I just saw something now. Once you swap, then you need to be checking I'm coming. Let me say index be equal to I. Okay, so this is why I did that. For example, now I is, what's this? This is 5. This is 4, right? So I is 4. I is equal to 4. So we try and check. We compare I array square brackets I, which is this. Is it less than array square bracket J? Remember, J starts at I minus 1. So that means J would be 3. Yeah, so it's 2 less than 5. You say yes, you swap. According to the previous code, it would come back and check again. I is still 4. Yeah, so to check array square bracket I, is it equal to I is still 4, but J has come down to become 2 because J is going downwards. Okay, so J is now here. So now it will compare 5 and 4, but instead it should be comparing 2 and 4. You understand? But since it's inside this loop, since I is gotten from this loop, I won't change until this J loop has run to the end. So we need something else to be tracking the position of this 2 that we're looking at. And that's why I created index and gave it the initial value of I. So now instead of trying to compare array square brackets I as we're going, we'll be comparing array square brackets index. So here, now we would say index. So as you swap, you change index. Index is now 3. So you check index, array square brackets index, and array square brackets j. Is the index, this one smaller? If it is, you swap both of them. So this will now become 2, and this will become 4. So index has come down. Index is now whatever j was. At this point, j was 2. So index is 2. J itself will reduce. J will become 1. So now you are checking these two. Arrays square bracket index and array square bracket j. Is this one smaller? Yes. You swap again. So this would be 2. This would be 3. Index is now 1. J is now 0. Aha. So array square brackets index, is it greater than array square bracket j? No. Well, in this case, a break is not necessary. But imagine, just imagine that there is maybe something else. Maybe there is -1. Right? Maybe there is -1 here, for example. Even as because we didn't swap here, this loop will still continue running. So it will still keep checking, previous things in the array. But that's a waste of time. So the moment we meet something, that meet a situation where array square brackets index is greater, or rather is not less than the thing before it, you break. You stop that backward loop at that moment, because you found the correct place where that value is supposed to be, and you move I forward and go to the next step. I don't know, this was a little long, but I hope you understood that why break should be there.
Sorry, I understand the process we are trying to follow, but what's the insert function supposed to do?
What's the insert function?
What's this insertion sort supposed to do? Is it not sorting according from the lowest to the highest, or?
It's starting from lowest to the highest.
What's the difference between this and the one we did before? The function we did before.
I don't know. Pretty much everything about them is different. Selection sort. You are finding the smallest number each time. Here, the smallest number is 1. You carry it straight to the front. No, you are not mincing words. We swap only once. You carry it straight immediately to the front. Then you check again. Smallest number, 2.
Okay.
Here, the position is already set. Is this position. You swap it immediately. Next,
okay.
3. You swap it. Just one swap. But the thing with this insertion sort, where are we? Yeah. We are growing our sorted array from the left, like from here. You see this mark is showing our sorted array. From this place to this place is the sorted array. If you check at every time, this place is always sorted, right? Ignore these ones. Just look at this place. This is sorted, right? This is sorted here. So we are growing the sorted array from the left and coming front. So each time you pick the first thing in the unsorted array, and then you now go back into that sorted array and keep finding where to keep it. Okay, so I used this to show an example. At this point, 2 is the thing left to be sorted. So we are trying to find where it should be in this array. So we check 2 and 5. 2 is smaller, so swap it. 2 is smaller than 4, swap it. 2 is smaller than 3, swap it. This was just for an example. 2 is smaller than 3, you swap it to get 2 to this place. 2 is greater than 1, no need to keep swapping. You found where 2 should be. You close shop, and move to the next turn. So is it clear now?
Yeah, it is.
Okay. So I guess instead of swapping all the time like this, we could get, another variable that will just be tracking j. Like here now we kept swapping. In the first place, let's see whether this works, and then we can, because having this swap function run so many times can, impede our speed. So console.log, what's that? Insertion sort. Uh, 5 3 4 1 2. Okay, so this didn't work. It's saying 3 5 1 2 4 3 5 1 2 4. So crazy things are happening. Something in here ain't right. So let's see how it was changing over time. Console.log array. So we started with 5 3 4 1 2. Then we got this. Then 4 was inserted properly. Then 1 was not inserted properly. But 2 was inserted properly. So the issue came from here. Why was 1 not inserted properly? So this, let me see. There are 4 things. So I is 1, I is 2, I is 3. So at this point, I is 3. So if I is 3, it means J was 2. Right? That should be this point. The sorting after this point. It just moved here and stopped. Why is that? If array square bracket index is less than array square bracket J, index is what? Index is 3. So if it's less, we move forward. Yeah, this doesn't. If array square brackets index, yeah, you move forward. Then index becomes J. J was 2. Oh, this 4 moved. It's 3 5 4 3 4 5. So it's tampering with our sorted part of the array. So this this one, the fact that this 5 moved is what's troubling me. This 5 had already come back, so how did it move forward? At this point, I is 2. Here I is 3. Hierarchical index is 1. J is 2. Okay, so let me try something. Instead of swapping all the time, what if we just kept, swap index? Let's call it swap index. Right? And what should it start at? It should start as I as well. So index is J, then swap index will become what? Swap index to become G. So at this point, zero and 1. Let me see. 0, 1. So it needs to be put in 0. J is I minus 1. How is this one? Console log G. Ain't that interesting? J starts at 0. Let me see. Break.
Baltimore.
Okay. So now I'm thinking of splicing this array. Let me see. Array is equal to, let me see. I is equal to 1. Okay, 1, 1. And then here we just insert that array that splice. Oh, this is not 1. This is I and 1. And then we splice in that norm into the right place. So we put it at index, we put nothing, or rather we remove nothing, but we put in norm. So if I console log array, so 4 comes, 3 comes in front, three comes in front, 4 comes in the middle. This 1 again, this 1 keeps on having issues. Why is that? Why does 1 have issues all the time? Array square bracket G. So this is 3 and 5. Okay. This is 4 and 5. Cool. This is 1 and 5 here. 1 and 5. And the next thing is 2 and 5. So I guess that's why it didn't pick 1 again to check. Array square bracket index. Index is 3 here. These are 1 and 5. Okay, this is just anyhow index is I. I've gotten why this thing is messing up. It's because it's losing that this index I created is losing track of, I created it to keep track of the thing we are focused on. Actually, this one is not necessary. If array square bracket I is less than array square bracket j. Okay, it's working now. So it was because this was index. Okay, so my bad. So there was no need for swapping actually. So at the end of the day, let me see, you look through the array, then this is here to keep track of where the next value should be inserted into. Okay, then you run a backward loop from where you are, backwards. Like this is the sorted part of the array, you are checking this one currently, you run a backward loop this way to check for where you should insert this one. Okay, so if at any point array square bracket I is less than array square bracket j, you make that j your new index and keep checking. Then if you meet one that doesn't conform to this, you stop the array. Like this is what I mean. Let's say this point, for example. Yeah, we can remove all of this. At this point, for example, 2 and 5, index is initialized as whatever I is, and I is okay. At this point I is 4, right? So you check these two, 2 and 5. 2 is smaller, so I becomes 3. 2 and 4, which is smaller, 2, so I will become 2. 2 and 3, which is smaller, 2 is smaller, so you give index the value of this index here, which is 1. So now this part, you will remove these 2 from where it is. That's what this is doing. Array.splice I, remember I is 4, so array.splice 4, 1. That means from that index I, remove 1 value. So the array will now become like this. Okay. Somebody just joined in. Yeah. Remove 1 value. So what you will get is like this. What this will be, just this. Is 2 in an array. So I just want the first value. That's why I did, square bracket 0. So that would give us 2. So now at this index 1, insert 1. Remove nothing. Remove 0 items. But insert none. So 2 will come here. That's how this works. Should I explain it again?
Yes, please.
Yes, okay. So, for starters, you are assuming that this... Hello? Okay.
Yeah, go on, explain.
So for starters, we're starting our loop at 1. I is equal to 1, index 1. Because we're assuming that I index 0 is already sorted, right? Imagine that this portion, whatever portion you see this marker at, from that portion to the beginning, just take it as an array of its own, right? So imagine that this, of course, an array with only 1 item is already sorted, right? So this is already sorted. We're trying to figure out where in this place we should fix this one. And so we decide to loop through that sorted portion of the array to decide where to fix the next item. So now this variable index is created. Let me call it insertion index so that it will be clear. Okay, so insertion index is initialized as whatever I is at the moment. Okay, so you loop backwards. Nothing is showing. Okay, because of this. No wonder, I just felt something go wrong.
Very far connection. Very far connection. What is it? What is it?
It's black. It's not yet showing for me. Still not showing. Why are you hearing my voice? All these networks will peak at the same time and decide to annoy you. Kicked you out. Hello guys, can you guys hear me?
Yeah.
Okay, yeah, sorry about that. My network just decided to bail on me. Can you see my screen?
Yeah.
Okay, so back to what I was saying. Yeah, we are at the beginning. We assume the first item is our sorted portion of the array, and so we pick the next item, and that's why we start with I as 1 and go forward. So we create this insertion index so that when we loop backwards into the sorted portion, we will know where to keep this next item. It's like you remove this and then you just start going back to look for where to drop it. So in this loop here is, you know, us looping backwards through the sorted portion of the array to look for where to keep the current item we're holding. Okay, so if we check array square bracket I, is it less than array square bracket j? For okay, this was the one I used to explain, because This one has quite a bit of movement, right? No, I feel like something is wrong. It's 3, 4, 5. 3, 4, 5, 1, 2. Okay, yeah, we had sorted it and 1 had come to this front. Because that's the next step after here. Aha, this is how it was. So, this is insertion. Okay. It's at this point, I is 4, right? Because here I is yes, here I is 1, 2, 3, 4. So I is 4 at this point. So we start our insertion index as 4 and we loop backwards. So j is equal to I minus 1, which is 3. So we check array square brackets I is 4, that's this one. Is it less than this one, which is array square brackets j? If yes, then insertion index, change the value, give it j, right? That means this one should come in front of this. Okay, so if we do that whole splice and then put back thing, this would end up being here. But we'll keep on moving forward because the fact that this is smaller than this doesn't mean that that's the end. Okay, we keep on moving forward. 2 and 4. Is 2 smaller than 4? If yes, again you change the insertion index to whatever this one is. Then you check again. 2 and 3. Is 2 smaller than 3? Yes, you change the insertion index. 2 and 1. Is 2 smaller than 1? No. So you break. You stop this for loop from running. At this point, it may look silly to break because this is the last thing to check. But imagine a bigger array where you are going back and maybe you stop here. You find yourself at this point and this is not smaller than this. Continuing to check the rest of this is a waste of time. Okay, so at that point you will see why that break is necessary. There's no point to keep checking. There's no point checking because this array, this portion is already sorted. So if you do meet anyone that is bigger than what you are holding currently, that's it. Or rather that is smaller than what you are holding currently. It means the things in front of it will also be even smaller. So no point checking. You stop there and you now have your insertion index. So you cut out that number from the array. That's this arrays dot splice I is 4. That's this. The square bracket 0 is just because when you splice something out, you get it in an array. Like you, in this case now, you will have 2 in an array, just 2. And so the square bracket 0 is to have the 2 in hand. Okay. And then now you insert it back. I could have done some weird things where I put comma array dot splice, but I didn't want to do that. I prefer to have it looking neat like this. Okay, so you splice out the number first and then do another splice to insert it back. Okay, and you know splice mutates the array normal, so everything, there's nothing else you need to do. At the end of the day you return the array. So just looking at this, look at this console log array and you can see how it's changing. So at first, remember 5 was in front, so after the first time the loop runs, 3 comes here. Then next time 4 is inserted in between here. Next time 1 comes all the way up here, and the next time 2 comes all the way up here. So it lives up to its name, insertion sort, because you insert, you remove something from where it is and just keep checking, where should I keep it, where should I keep it. You find where it should be, insert it there and go and pick the next number and look for where to insert it, insert, go back and pick the next number, like that. So as you can see, actually this is my first time of creating these three algorithms. The main thing to keep in mind is just the pseudocode. How exactly does this thing work? As long as you know how this thing works, you kind of have it in your head. Okay, this one I'm looking for the largest values, this one I'm looking for the smallest values, this one I'm looking for where to drop it in here. At any point in time, last it's just a few extra minutes or something, you know what to do, you figure out what to do.
Sorry, I don't understand what the.
You don't understand what? Hello? I thought somebody was talking. Okay, so do we have any
Sorry,
questions?
I don't understand what that non-variable, that splice, what is supposed to do? What the non-variable splice supposed to do?
I just went over it right now.
Rounding up, please.
I'm rounding up. At the end of this loop, the point of this loop is just to get this insertion index, where you are fixing the number, you're inserting the number you're trying to sort or fix at that moment. So after the loop, you cut out that number. That's what this splice is for. In this case, okay, here for example, we are cutting out 4. Can you hear me? 12. Can you hear me? From one wahala to another wahala. Can you guys hear me?
We can't hear you.
Are you seeing anything?
Oh, your network, bro.
Is this one now trying to force me to go to 3G?
So I was saying that you should explain that non-variable, that splice, that line 141 and 142.
The same thing irritates me. Can you guys hear me? And it has gone again. Can you guys hear me?
Yeah.
Yeah, better now.
Yeah. Now.
Okay, sorry, I didn't even know I was talking to myself. Okay, so about that norm, just going through it again. Here,
Yes, we are not showing your thing.
okay, right. The same thing wants to just annoy me today. You can see it, right?
Yes.
Okay, so basically at every point in this outer loop, whatever is at index I, we are cutting it out of the array. We are removing it. That's what that splice is for. You see, num is equal to array.splice I and 1. That means whatever is at I, or rather start at I and remove one item. That's what this splice is doing. So when you are done with this, you will get something in an array. For example, at this point, you will get 3 in an array like this. Just one item in an array. So I did square bracket 0 so that I'm holding just 3. So that num is holding just 3, not 3 in an array. Do you understand that?
Yes.
Okay. So now insertion index It's just a variable that is holding the index for you to insert that number back into. Because look at it here now, you remove 3 from here and you check through this sorted portion, you see, okay, it's at index 0, I should keep 3, so you keep 3 there. Here you remove 4 and you check, and it's smaller than this one, it's bigger than this one, so it's here at index 1 that I should keep this 4. Here 1, we check here, it's smaller, you check this one is smaller, check this one is smaller, and so you say it is 0 that I should keep this one, at index 0 I should keep this one. So you understand how the insertion index, what is there for?
Yeah.
Okay. So you've gotten norm, and at the end of this loop, you have gotten your insertion index. So you splice it back in. You say at insertion index, remove nothing, insert norm, and that's it. Is this for loop confusing?
So wait, I want to understand.
Yeah.
For the outer for loop you run. Okay.
Yeah.
Take the first I equal to 1. That's at index 1. So that at that index 1, the second for loop we run until it gets to the end, right?
Yeah, it's going backwards. The second for loop is going backwards. Like, you see all this dash. You see how the dash is coming forward? That dash is showing the sorted portion of the array. With insertion sort, you start with a sorted portion and you keep growing that portion and going forward until it covers the entire array. And that's what's happening. 5 is the sorted portion of this array, because an array with only, just take this 5 as a separate array on its own. An array with only one item is sorted because, I mean, there is nothing in front or behind it, so it's sorted. So you pick 3 and try to keep it, in the right place.
Okay.
You can hear me, Abi?
Yeah, I can hear you. I can hear you.
Okay. Yeah, you pick 3 and try to keep it in the right place. You pick 4, you try to keep it in the right place. So the second for loop, you are going backwards. Let's take this 2 for example. You are looping backwards. You check 2 and 5, you check 2 and 4, you check 2 and 3, you check 2 and 1, like that. So that's why the j in this second for loop starts at I minus 1. I here is 4, so j would start at 3, because this is 3. And it's going down, minus minus, it's stopping at 0. J less than or greater than or equal to 0. So each time you check array square bracket I, which is 2, and array square bracket j. Is this one smaller? This and this, is this one smaller? If yes, you change your insertion index to this. Then you move again. The j will get smaller to become 2. So you check, is array square bracket I less than array square bracket j? Yes. You change insertion index again. 2 array square brackets I, is it less than array square bracket j? Yes. Change insertion index again. Array square bracket I, is it less than array square bracket j? No. Break. Stop the for loop. Your insertion index is correct as it is. So now you can now remove norm and you know where to keep it.
So my confusion is, what sets I to 4?
Where did you see
what sets j to 4? Or I to 4?
Where did you see I or j set as 4?
So you start from 4 now. J starts from 4 and
I'm talking of this place now. At this point, well, with me when I explain this one. This is sorted. At this point, I is 1. At this point, I is 2. At this point, I is 3. This is just like let's say time lapse or something, just showing how the array is getting sorted slowly and coming forward. You can see the changes now, or you can also see it here, console log array.
Okay.
After the first turn of the loop, this is what it looks like. 3 will come in front. After the next turn, 4 will come here. The next time, 1 will come to the front. You see, we just pick a number you pick the next number and keep it where it should be. 1 comes in front here, then 2 comes here, and bam, you have it completely sorted array. The reason why I said J starts what's this one? The reason why I said J starts at 3 here is because at this point I is 4. This is just showing different steps of the loop. Loop starts here, goes here, goes here, goes here, goes here. You don't finish. Is this still confusing? Is that yes I heard?
Yeah, I have a question. Can you hear me?
Yeah, I can hear you.
Okay, so why didn't we use swap function that you created earlier? Why did we switch it to splice?
Why did you
Is there a reason?
Well, no particular reason. Well, okay, I felt it will make things a bit shorter. Here we don't necessarily need to swap per se. You can just splice at the end. But okay, if we were to make this something swap, it's just that there's no time at the moment to get that swap part to work. But on your own, since you know how insertion sort works, you can try it out. Once again, I will push this to GitHub, so you will see the swap function there anyway.
Okay, thank you.
Yeah, and you guys can also try. So far, this sorting we've been doing has been ascending order, small to big. So you can try tweaking these functions to make it go from big to small, right?
Okay.
Okay, so that's all for somebody who have my name. I hope you guys enjoyed today.
Yes.
Alright, so we'll see you again tomorrow for merge sorts, quick sorts, and radic sorts. Please brush up on recursions, because tomorrow I will assume you all know recursions. I'll take it like a done deal. I will not explain recursion.
Okay, sir. Thank you very much.
Welcome.
Thank you.